All right, in lesson 353, we want to compare linear functions to exponential functions as opposed to linear, and linear exponential, exponential like we did in the last two lessons. So there will be some key features we want to focus on while we're doing this, and some of those are listed here. The first part of these is some stuff we should know about linear functions, all that kind of stuff, and then some things we should know about exponential functions. The two that I want to draw your attention to are these bottoms here right here. Okay, graphs of exponential functions of the form g of x equals a times b to the x power, where b is greater than 1, will increase faster than graphs of linear functions of the form f of x equals mx plus b. Okay, in other words, over time, the exponential function will always exceed the linear function, assuming that they're both increasing. Okay, so that is super important. That's probably the most key piece of information about this whole lesson. All right, so on to a couple of examples. Example 1, which function increases faster? F of x equals 4x minus 5, or g of x equals 4 to the x power minus 5. Justify your answer with a graph. Before I go to a graph, before I look at a graph, I want to get some ideas of what these points actually look like. So I want to do just your basic table. Okay, and we'll go from -2 to 2. If I plug in here, I get -13, -9, -5, -1, and 3. Okay, and we do the same thing for g of x. Take a minute, pause these, plug them in your calculator just to make sure that you get the same things that I do. Okay, this one you get -4.9375, -4.75, -4, you get -1, and you get 11. Okay, now I want to go ahead and point out also before we go any further, this right here. Okay, these do actually connect, they do actually touch at 1, -1. Okay, so now that you got those, you go through and plot them, and we want to see what they do. Okay, so I'm going to have to erase these to make them go away for just a second, but what you should see is that this is what the graph looks like. Okay, you got your asymptote at -5. Okay, you got your asymptote down here, -5. That's the line that the exponential is approaching but never touch. And then you got your linear function. And what you have right here, we said at 1, -1, that's the point where they intersect or where they touch. In this case, it looks like they simply touch. But what you really should notice is that over here, the curve is very flat. Okay? And so the rate of change is much smaller than the linear function. But after this point, what you should notice is that this one, the exponential, is now increasing at a much faster rate than the linear function. The linear function is constant all the way through, right? It's moving at the exact same rate of change the whole way through. Whereas the green rate of change is indeed changing, it's increasing. And after that point of contact there, you can see that it's increasing much faster. Actually, probably before that, somewhere around this area where it starts to go up at a much faster rate. It's got to catch up. All right, so that's what we're noticing about that. And that's what you're looking at in this lesson, is the fact that, generally speaking, exponentials will always exceed their linear counterparts. Okay? All right, so at approximately what point does the value of f of x exceed the value of g of x? In other words, at what point do the y's become larger? If f of x is 2 times 4 to the x divided by 20, that fraction being a power, and g of x equals 0.5x. Justify your answer with a graph. So, again, do your table of values. Let's see if we have a graph here. All right, so at what point, so here's g of x, and here is f of x. So f of x being the curve, so when does f of x exceed g of x? Okay, well, anywhere back here, right? Anywhere to the left of this point, f of x exceeds g of x. F of x, yes, exceeds g of x, right? F of x is above, the red line is above the blue line. So basically, any point leading up to 6, right? Any point leading up to 6, f of x will be greater than g of x. And then again, at any point after 28. Right? At any point after 28, to the right of 28, so 28, 30, 31, 32, so on and so forth, f of x will be greater than g of x, right? Because our line, our red line, is above our blue line. And then the same thing is true for any number less than 6. Because again, our red line is above our blue line. For any value between 6 and 28, right, g of x is actually greater than f of x. So on that one little tiny interval, right, that small interval, g of x linear function is actually above, it's higher. Okay? But in the end, as we keep moving to the right, eventually the exponential will exceed that linear, always. Okay? All right, we're going to go one more. Lena's been offered a job with 2 salary options. The first option is modeled by the function given here, so f of x. And then the other one is modeled by, her second option is an exponential. Okay? If she is hoping to keep a position for at least 5 years, so really we only care about the 5 mark, which salary option should she choose? So again, I would recommend that you start with the table. I would recommend highly that you start with the table. And this is the table for this one, already provided for you. Basically just plugging in the f of x and g of x. And what you should see, hopefully, is that the meeting point is somewhere in between there. Okay, they're actually going to intersect somewhere between there. Probably not exactly at 3, but pretty close to it. Okay, so you might can already jump to your conclusion based on that. However, let's look at the graphs. Okay, and even though this doesn't really look exponential, even though this one right here doesn't look super exponential, you can't see the big curve, it doesn't mean it's not there. There is a slight curve to that red function, the g of x. And what we should see is that somewhere right around the 3-year mark, the exponential function g of x exceeds the linear function. So if we care about 5, then we're looking at this value right here, which means we can tell that g of x does indeed exceed f of x. Okay? So making sure you're able to graph and plot points and all that kind of good stuff, you're going to have to be very close with your graph. So always start with a T-chart for doing that. Okay? Good luck with 353, guys.